Welcome to BitStop, a better way to bus. BitStop is our answer to a looming problem in the US: inefficient and constrained public transit systems. The people of cities like Atlanta deserve to have reliable public transportation, and better routes can be developed. That's why we developed BitStop, a website built with a Django backend, React frontend, and Chakra UI that utilizes foot traffic data, custom heuristic route generation algorithms, and more to determine locations most in need of public transit and generate an optimized bus route to connect them.
Our first example is a generated bus route network for Hyderabad, India. Our list of sites is obtained from the Best Times API, which returns high foot traffic areas. We created a graph using these stops, which we then put through our algorithm to create a bus route network. Next, we'll create routes for a completely different city, Atlanta, Georgia. Each node in our graph represents a stop, which has a weight based on its normalized foot traffic.
Each edge has a weight based on the travel time between the nodes, calculated using the distance matrix API.
Our graph starts out looking like this, and after our algorithm, it looks like this.
The core of our algorithm is a cost function that assigns penalties to long and disconnected routes. We first create routes that start from randomly sampled nodes, and our genetic algorithm then mutates the routes and iterates on the routes that have the most optimized total cost. Finally, we simulate a probability-based annealing algorithm that mimics the cooling of metals to approximate the optimal route system even for complex networks like large cities.
Now you can see how a user would suggest a stop to be added to the route. BitStop paves the path towards a better future, making public transport more accessible, environmentally friendly, and equal. People get a transport system that responds directly to their needs and habits. This will improve the economy, community, and mental health of all those in the city. Here's some research that we based our project on. According to Johns Hopkins University, 15 million American adults face unreliable transportation. 45% of Americans have no access to public transportation, but every $1 invested in public transportation generates $5 in economic returns. The people deserve to have functioning bus routes that work for them. Our biggest challenge was optimizing the route generation algorithm and fine-tuning the countless parameters in our heuristic algorithm to account for edge cases. One specific issue was that our cost function initially incentivized the creation of long bus routes for bus stops for only a small portion of the population. We fixed this issue by implementing a threshold penalty that penalizes excessively long routes in our optimization process. Throughout the process, we considered many different options for APIs and algorithms to generate the bus routes.